So again, we're going to talk about linear equations in two variables. This is the standard form. Okay, well, you're going to want to recognize when an equation is in standard form, and for our linear equation, that means any equation that looks like this: ax plus by equals c. A, b, and c are numbers. So for example, an example would be 3x plus 5y equals -7. So that would be a linear equation in standard form. Notice we have the x and y variables on the left side of the equation with their coefficients, and then we have the constant c on the right hand side, -7. When you have an equation that is of this form, the graph will be a line. So we're going to do some graphing, and you're going to notice that the graph is a line. And then an order pair is going to be a solution if the equation is a true statement when the x and y coordinates of the order pair are substituted into the equation. So that's one of the first things we're going to do in this video is, given an order pair, let's determine if it's a solution of the linear equation, which is going to mean that we're going to substitute and see if we get a true statement. Okay, and then finally, every point on the line is a solution of the equation. So in our previous work with linear equations in one variable, we would get one answer that made the equation true. Here with our linear equation in two variables, every single order pair that's on the graph of that line, every one of those pairs is a solution. So that means we could potentially have infinite number of solutions, since lines are made up of infinite number of points. So you'll see that as we go along. Okay, let's try a couple of problems now. Determine whether each equation has the given order pair as a solution. So number one, we have 3y minus 2x equals -8. And we're trying to determine if the order pair 2, 4 satisfies this linear equation. In that case, we would say that that order pair is a solution. If it doesn't satisfy the linear equation, if it doesn't give us a true statement when we substitute, then that would mean that the order pair 2, 4 is not a solution to this equation. Notice that this equation is in standard form, but the orders a little reversed here. So to rewrite it in standard form, we would put -2x plus 3y equals -8, and I'm just reminding you again that the standard form was ax plus by equals c. Okay, and you can tell me what a, b, and c are. You can see that, can't you? Okay, so now we're checking. So substitute. So the order pair is 2, 4. So that means x is 2, means that y will be 4. So we're going to go ahead and substitute right into our equation. So -2 times x plus 3 times y, and we're checking to see if that will give us a -8. And if it does, then this order pair is a solution. So let's see what we have here. We have -4, multiplication before addition, right? -4 plus 12 is +8. We needed this order pair to give us a -8 when we substituted it into the equation. So guess what? These are not equal. This is a false statement. So what does that mean? That means that the order pair 2, 4 is not a solution to the equation. Not a solution. Example 2, we have y equals 1/2 x plus 3. Now this is not standard form. Do you see that? Do you see that this linear equation here, we have our y and x in different parts of the equal sign. Do you see that? You're going to learn that this form is called slope-intercept form. Now you don't have to keep track of that just yet, but I want you to start being able to recognize it, because this slope-intercept form is going to be really important later in this chapter. And that's usually a form where the line is written like this: y equals some number m times your x variable plus another number b. And that's the form of the line that we have in this given equation. We're still going to go ahead and check. We got to check to see if this order pair -2, 2 is a solution. So we're still going to go ahead and substitute. And again, sometimes it helps to label your order pair, the x and y. If that helps you, just kind of keep it in mind. The other thing is that it's alphabetical, by the way, just in case you forget. So x comma y in the alphabet. So the first coordinate is your x coordinate, and the second coordinate is your y. So I'm substituting them right in. So 2 equals 1/2. We don't know if it equals, that's what we're checking. 1/2 of -2, which is x, add it to 3. And then when we do this multiplication over here, it will help to put a 1 under that, and maybe you can see here that we get, when we multiply straight across with those fractions, that we get negative 2 over 2, which is reduces to a negative 1. And negative 1 plus 3 does equal 2, doesn't it? That checks. So what can we conclude? That means that the order pair negative 2, 2 is a solution. Notice I didn't say the solution. I said a solution of the equation. Okay, and we know that this line, because think about what you know about a graph of a straight line, it's made up of infinite number of points. So negative 2, 2 is not the only solution to the equation, but it is one of infinite.